Hi, I'm Santosh Balasubramanian, Program Manager in SQL Engine, and I'm here to talk to you about our new high availability and disaster recovery solution, AlwaysOn. For folks who are familiar with SQL Server HADR technologies, you would know about database mirroring, which is for database level protection, SQL Server failover cluster instance for instance level protection, log shipping, which is used for DR, and sometimes, depending on the topologies, you would use a combination of database mirroring for local HA and log shipping for DR. But these are some of the things that we were thinking about, and we took a holistic view at high availability and disaster recovery. And in 2012, the three main pivots that we came over with was we want an integrated solution, a single unified solution. We do not want you to be thinking about database mirroring and log shipping for your topology. We want a flexible solution. We want you to be able to reuse your existing assets. If you have shared storage or if you have direct attached storage, you should be able to use all of these, whatever is there in your topology, in this single solution. We want there to be an efficient solution. What this means is all the servers, all the assets that you have acquired for your high availability and disaster recovery, you should be able to use them. All of this is what will improve the IT efficiency. Based on this, we came up with two new solutions: AlwaysOn availability groups for database level protection and AlwaysOn failover cluster instances for instance level protection. For the rest of this talk, I'll do some demos on AlwaysOn availability groups and talk about the new features in AlwaysOn failover cluster instances. AlwaysOn availability groups. AlwaysOn availability group is what combines the functionality of database mirroring and log shipping and provides a lot more features and capabilities on top of this. For example, you can failover multiple databases as a single unit. With database mirroring, you have to set up mirroring on only one database. So if your application depends on multiple databases, you have to set up mirroring on each one of those databases. In AlwaysOn availability groups, you can take all of those databases as a single unit and failover all of them. Multiple secondaries. In database mirroring, you have only one passive mirror. With AlwaysOn availability groups, you can have up to 4 secondaries or 4 mirrors for one primary. Out of these 4 secondaries, 2 of them can be synchronous, and of these 2 synchronous, one of them can be an automatic failover pair. You can also, in these 4 secondaries, you can also have asynchronous or synchronous secondaries. So you can set up your local HA, your regional HA, and DR in this one single availability group. You also have built-in encryption, compression, automatic failover, manual failover, flexible failover policy, as well as automatic page repair. All of these, some of these are features also in database mirroring. Okay, integrated. The failover is more than the failover of just the database. Your application also needs to be able to reconnect to your new primary that you do a failover to. We achieve this using the availability group listener, or the virtual network name. I will actually do a demo of this. Also, we have done a lot of work into improving the configuration. So we've done a lot of work into the wizard, dashboard to show you the view of your availability group, all the databases, all the secondaries which are there, what is the state of each of these secondaries and databases. There is COM integration, you have rich diagnostic tools, publisher failover. You also have contain database, file stream, file table, as well as service broker. Right? Efficient. We want you to be able to use all the secondaries that is there in your high availability and disaster recovery solution in your availability group. You can do this with AlwaysOn availability groups. You can use your secondaries for doing readable queries. So read-only applications, such as your reporting applications, can point to your secondaries. Or you can use it for offloading backups from your primaries. You can do your backups from the secondaries. All of this, the setup, configuration, management, failovers, all of this can be done using PowerShell as well. All right, so let me do a demo right now. Let me tell you how people would have set up currently before AlwaysOn availability groups and how we will do the setup of this with availability groups. Currently, say your infrastructure or your topology is you have 2 servers in one data center with automatic failover and database mirroring, and 2 other servers which has log shipping targets. Let me convert this into a single availability group. So in this demo, as I had shown, we will have 2 servers which have local HA, one which has regional HA, and one which has DR side. So we will convert the database mirroring and log shipping configurations into an AlwaysOn availability group. I have 4 servers here, AlwaysOn SRv2 and AlwaysOn SRv3 that I will create my local HA, AlwaysOn SRv4 which I will create my regional HA, and AlwaysOn SRv5 which is my DR site. The first thing that you need to do with AlwaysOn is ensure that there is a Windows Server Failover cluster which has all the servers which are a part of your availability group. In order to do that, I can go to the Failover Cluster Manager, right click, say create a cluster, and add all of these servers. For purposes of this demo, I have already created my cluster with SRv2, SRv3, SRv4, and SRv5. The next thing that you need to do is go to SQL Server, Configuration Manager, right click your service, go to Properties, and you will see a new tab, AlwaysOn High Availability. Enable AlwaysOn High Availability and click and restart your service. You will have to do this in each one of the servers. After this, all the configuration, creation of the AG, management of the AG, all of this can be done through SSMS. One other thing is the previous actions which I had done, which is enabling availability group. All of these could be also done using PowerShell scripts. Let me create an availability group. I will connect to AlwaysOn SRv2, which I want it to be my primary. As you see, I have 2 databases here, AdventureWorks DW and AdventureWorks REF. I'm going to create an availability group with both of these databases. To create it, I right click availability group, select the new availability group wizard, next specify a name, say I will do VLE-AG1, select the databases. As you notice, I'm selecting multiple databases, and add replicas. So replica is the term that we use in availability group, what I've been using as servers. All these servers are replicas. You have a primary replica and you have your secondary replicas. So my primary is AlwaysOn SRv2. I will add my local HA, which is SRv3. I want this to be synchronous because I don't want any data loss, as well as I want automatic failover to happen to this. Now let me add my regional HA data center. So regional is there is low latency. I know I want data to be protected in this one, so I want this to be synchronous. Sorry, that is SRv4. So I select synchronous here, so my data is protected with no data loss across 2 secondaries. And then I'm going to add my DR site, which is AlwaysOn SRv5. Here this will be asynchronous, so there could be potential data loss when I do a failover to it. Okay, the next thing I'm going to do is add the listener. The listener is what I had talked about before. This is what I will use for my application to connect to the primary of my availability group. I am just going to call this listener, say AG1. Port, add a port which is default, and the IP. Next, data synchronization. So this is basically backup restore of the databases to each one of the secondaries from the primary. You have multiple options. I'm going to use full here, which is I want the backup and restore to happen to each one of the secondaries. Join is I've already restored the databases in the secondaries. I just want it to join the availability group. And the third one is I want the synchronization to skip, and I will do the backup restore later. So a set of validations is happening right now. This is the summary of what I'm going to do. I can click on script and get the script for it. Finish. Now we are creating our availability group. One of the important things in creation of an availability group or in availability group is each of these servers have their own direct attached storage. So like failover cluster instances, there is no shared storage requirement. You have to have a Windows Server failover cluster, but no shared storage in always-on availability groups. You can have failover cluster instances as a part of your availability group if you want, as one of the replicas if you want. We use the technology similar to database mirroring, where we do physical log movement to move the data, your log, between your primary and each one of your secondaries. Okay, so right now let me come back to the wizard. It has finished the restores. It is joining all the databases, as you can see, and your availability group is created. All right, let's go look at this availability group right now. I am going to show you the the dashboard of the availability group. Here you can see in the dashboard, you have a primary, which is SRV2, my local HA, which is the secondary with automatic failover. Synchronized means it is synchronous, no data loss. SRV4 is another synchronous server or another synchronous replica that I added to my availability group, and SRV5 is my DR. It is showing synchronizing. That means it is asynchronous. Okay, so now let me show you an application which will connect directly to this availability group. So I created the listener name, availability group listener name, which was AG1. I'm going to remove this old database mirroring failover partner connection string. My application used to use that. And when I click on change, you see that your application is automatically connected to AlwaysOn SRV2. Let me do a failover here and show you that your application will reconnect to the new primary when I do a failover. I'm going to have both of these on side. You're saying that the application is inserting some data. To do a failover, I'm going to use the failover wizard. I will click next and select SRV3. Let's assume the reason I'm doing this is because I'm patching AlwaysOn SRV2. Click next. I have to connect to AlwaysOn SRV3. And now I'm doing my failover. While I'm doing the failover, of course, the application needs to, the failover process is happening, and hence the application is not connecting. But the application has retry logic, which has to be built into the application. This retry logic will keep on trying to connect to AG1, which is the listener name. Now, as you see, I didn't do anything to the application. The failover happened, and the application connected automatically to the new primary, which is AlwaysOn SRV3. So what did we do here? We created an availability group with multiple databases, multiple secondaries, added a listener, did a failover, verified that the application connects automatically to the new primary. All right, so now let me show you the readable secondaries functionality. Let us assume the situation is that your primary is getting overloaded, you're a 24/7 business is growing, so you want to offload some of your reads, some of your reporting to your secondaries. In order to do that, the first thing I'll do is connect to the new primary, which is AlwaysOn SRV3. Here is from where I have to do all the configurations for the availability group from the primary. I select my availability group, right click, go to properties, and here you see readable secondary. What this is when your server or replica is in secondary role, I want to be able to do reads from this. I click OK. So now it is enabling readable secondary in each one of the secondary replicas. The next thing I want to do is I want to set up something called read-only routing. What this is from your reporting application, I want to be able to connect directly to the readable secondary. Even when I do failovers, automatically it should connect to the readable secondary without me having to do any changes. So for this, I have a script for setting up read-only routing. For read-only routing, you need two important things. One, you need to set up a routing URL. So for the secondary, what do I need to connect with? For example, here for my availability group VLE AG1, I have for SRV2 routing URL. For each of the secondaries, for each of the replicas, I have a routing URL. Then I set up my routing list. What this means is when the primary is on AlwaysOn SRV3, I want the readable connection to go first to SRV2. If SRV2 is down, then I want it to go to SRV4. Similarly, when the primary is SRV2, I want it to first go, the readable connection to first go to SRV3, and if it is down, then go to SRV4. So let me execute this query. This is completed. Now I have a reporting application. In this reporting application, first let me show you if I use the data source AG1, which is the listener for my availability group, you will see that the reporting application automatically connects to the primary, which is AlwaysOn SRV3. Also, you can see this in the dashboard that your primary is on AlwaysOn SRV3. But I want this to connect to my readable secondary. I've already set up my routing list, and the next thing I need to do is I need to add this keyword called application intent equals read only. Click on change, and you see that my application, my reporting application, has automatically connected to my secondary, which is AlwaysOn SRV2, and doing reads from there. All right. So let's do a recap of the demo. I created a single availability group with multiple databases, had multiple secondaries. So I had my local HA, my regional HA, both of these synchronous, and my DR site, which is asynchronous, in the single availability group. I performed a manual failover without data loss. I created a listener, which I referenced from my application, and I was automatically able to connect from the application to the new primary. And after that, I also offloaded the read-only application to the readable secondary. So I had my reporting application, which pointed to the readable secondary using read-only routing. Now let me talk about the other active secondary feature, which is backup from secondaries. You can offload your backups to any of the secondaries. You can also do your backups from the primaries if you choose. You can do copy-only full backups or log backups from your secondaries. The log backups which are done from all replicas form a single log chain. We always recommend that you store your backups in a single location. We also have a database recovery wizard, which makes the restores much simpler of your backups. All right, so that is all the features in AlwaysOn availability groups. Let me talk about AlwaysOn failover cluster instances. Think about AlwaysOn failover cluster instances of enhancements that we have done to the current SQL Server failover cluster instances. Some of the major enhancements are faster instance failover. We have done some work into the recovery stack, native support for multi-site clustering. So what this means is, say your AlwaysOn failover cluster instance is across two subnets, and you're referencing the primary using the virtual network name. If a failover happens from one subnet to another, your application does not have to make any change. You can always reference the primary irrespective of the subnet from using the same virtual network name. Then we have a flexible failover policy. I have the next slide where I will talk about it. We have support for SMB, and this helps with the consolidation of 26 drive letters. And you can also have your tempdb on your local drive, so you do not need to have it on your expensive SANs. All right, let me talk about flexible failover policy. What we have currently before SQL 2012 with SQL Server failover cluster instances, the way the cluster knows that SQL Server is alive is by making @server name calls. There are some situations where there's too much stress on your SQL server or worker thread exhaustion that your server will not be able to answer back to these calls. So what happens is the cluster might assume that your service is down and do a failover. So this can cause false failovers at very rare situations. We have improved this by actually having a stored procedure, SP Server Diagnostics, which is always running inside SQL Server, and it sends health information about SQL Server to the cluster. Health information such as, are there too many unresolvable deadlocks? Is there memory issues? Are there too many spin locks? You as a customer can then choose from a value of 0 to 5, what error situation do you want a failover to happen for? When do you want this automatic failover to be triggered? 0 being, even if SQL Server service is down, I do not want to do a failover. 1, only when SQL Server service is down, I want to do a failover. And incrementally till 5, when I'm having too many unresolvable deadlocks, I want to do a failover. So basically, based on your setting that you have done and the value that comes from SQL Server, if both of them match, then an automatic failover is triggered by the cluster. All this information is also saved, so you can actually use it for diagnostic logs and seeing what are the conditions which led for your automatic failover to happen. All right, so I've talked about AlwaysOn availability groups. I've talked about AlwaysOn failover cluster instances. Let me talk about a few more things that we have done for your availability and helping with disaster recovery. All right, so we support Windows Server Core with AlwaysOn availability groups and AlwaysOn failover cluster instances. This reduces OS patching by around 50 to 60%. We support rolling upgrades and patching with SQL Server. We have done some work into the recovery stack to improve the failover times. And we also have new online operations such as lob index, as well as adding columns with defaults. All of these will also help with your availability. This is a slide which gives you some information on resources and information on AlwaysOn. You have the RC0 download here, documentation, team blogs, and everything else. Please go here to understand a little more about it. And in conclusion, I've shown that we have a simpler, unified, single solution that you as a customer can use with SQL 2012 when you think about high availability and disaster recovery. We have done a lot of work into the management experience, System Center, management packs. We have filled some very, very essential gaps. We have online operations that we have done some work with, better health diagnostics with less patching with Windows Server Core, support for SMB and thus removing the NAS and drive letter limitations. And one other big thing is AlwaysOn availability groups is what is going to be the foundational future of high availability and disaster recovery from SQL Server. This is really a big step for meeting the customer's needs and the enterprise needs in HADR. Thank you.